So in chapter 1.4, we're going to be solving quadratic equations. I would like you to review the pages in your textbook 135 through 144, and please look at some of the problems. We will, in this chapter, hit these major objectives. I'm going to go over the square root principle. We will have an example of solving by factoring and using the zero principle, an example of completing the square to solve a problem, and finally we're going to use the quadratic formula. The first objective is using the square root principle. The square root principle is just taking the square root of both sides of the equation. So in our first example, number 33 on page 145, we have the following equation. T minus 1/2 squared is equal to a negative 17 over 4. So when we take the square root of both sides, we have t minus 1/2 on the left side of the equation, and we have a plus or minus square root of a negative 17 over 4. Now, if you come down here, we have t minus 1/2 is equal to plus or minus square root of 17i. Remember, I is the square root of a negative 1 by definition, divided by 2. We just took the square root of both the numerator and the denominator. Now I have t is equal to, I take and add 1/2 to both sides of the equation, and I get t is equal to 1/2 plus or minus the square root of 17i divided by 2. And we can combine numerators under the same denominator, or we can have t is equal to plus or minus square root of 17 over 2i. So that is our final result. So in our second objective, we are going to solve using factoring and apply the zero principle. The zero principle is where we put all of the terms on one side of the equation and set it equal to 0. Once we have the factors, then each factor can be equal to 0 to solve the problem. So in our example, 6m parentheses m plus 4 is equal to m minus 15. We're going to expand the equation first. When we do that, we get 6m squared plus 24m is equal to m minus 15. In using the zero principle, we're moving all of the variables over to the left side of the equation. When we do that, we combine like terms. We get 6m squared plus 23m plus 15 is equal to 0. And we notice that in fact we can bring into two factors this equation. So this equation goes into two factors. We know one of the factors we think is going to be 6m and the other one's going to be m. And how we know that is because 3 times 5 is 15. And if we multiply 3 times 6, we get 18. And if we add 18 to 5, we get 23. And so that's the middle term. So we have now, we can factor. We have 6m plus 5 times m plus 3 is equal to 0. Notice that if we expand this out, we get the original equation. So that's always a good thing to do. Now we have the zero principle. We can use each factor can then be set equal to 0. So we have 6m plus 5 is equal to 0, or m plus 3 is equal to 0. And when we solve for m, we get m is equal to a negative 5/6 or m is equal to a minus 3. So our solution set is negative 5/6 and negative 3. And you always want to check your answers, so when you plug it back in, these work. You may want to do that. The next objective is solving completing the square. So in completing the square, what we're going to do is we're going to set the equation ultimately not equal to 0. What we're going to do is take the middle term, the t term, in this particular case, take half of its coefficient and square it, and then add it to both sides of the equation. So this is problem number 45 on page 146. The equation originally is t squared minus 8t is equal to a negative 24. So we take 1/2 of the middle term, which is the negative 8, and we take negative 8 and we divide it by 2, which is half, and we square it, which is 16. So we add 16 to both sides of the equation, and that's what we did in that equation there. T squared minus 8t plus 16 is equal to a negative 24 plus 16. Now I can complete the square over on the left-hand side. I get t minus 4 squared. That makes it the perfect square. I can combine the numbers on the right-hand side, and I get a negative 8. Now I use the square root principle, which is t minus 4 is equal to plus or minus the square root of a negative 8. And so I have a negative, or a t minus 4 is equal to plus or minus 2i, square root of 2. Remember, I is the square root of 1. And now t is equal to, if I add both sides of the equation by 4, t is equal to 4 plus or minus 2i square root of 2. So my solution set ultimately comes down to 4 plus 2i square root of 2 and 4 minus 2i square root of 2. In the book, sometimes they show it in that regards, or they'll show it as this as the solution here. Our final objective is using the quadratic formula. There are many times when we have to use the quadratic formula to solve a quadratic equation, primarily because it's just easier to do. And if you remember, the quadratic formula is in blue up here at the top. And so if I have an equation, ax squared plus bx plus c is equal to 0, x, the solution for x, is equal to a minus b plus or minus the square root of b squared minus 4ac divided by 2a. Well, the problem I'm working is number 63 on page 146. We're going to solve for c, and so here's my original equation. I'm going to put it in the format, the zero format, the zero principal format. So I have 5c squared minus 7c plus 3 is equal to 0. Now I'm just going to substitute the coefficients in for the letters of the quadratic formula. So c is equal to a minus 7 plus or minus the square root of a negative 7 squared minus 4 times 5 times 3 divided by 2 times 5. That gives us 7 plus or minus the square root of 49 minus 60 divided by 10. C now is 7 plus or minus the square root of a negative 11 divided by 10. So now I have C is 7 plus or minus the square root of 11i divided by 10. And so here is my solution set. That concludes our major concepts for chapter 1.4. Please go over the problems, some of the problems in the text, and we will be then going into applications of using the quadratic equation.